This next unit, this next topic, we're going to look at logic, or what we can do with numbers. Specifically, we're going to be focusing on binary numbers. And so binary, as I said in the previous lesson, it's used in computers because it's easy to physically represent or electrically represent. We can have two states, and those can represent 0 or 1. So for example, if there's electricity flowing through a wire, that could be a 1. If there's no electricity, that might be a 0. And so typically we think about 0 as off or false, and we think about 1 as on or true. And so that kind of can help you think about this logic of if 1 is true and 0 is false, then we can see how kind of our language works with these circuits. So logic, when we're talking about logic in computers, we talk about these specific logic gates, ways to combine two values. So there are 6 different logic gates for all the possible patterns. That's the important thing, is just that there's 6 different logic gates for 2 inputs, I should say. And if you care about the math, or you want to know kind of this extra bit here, you don't need to worry about it, but here's the reason why. It's because if there's 2 inputs, there's 4 combinations of inputs, right? Both zeros, the first one 0, the second one 1, the second one 0, the first one 1, and both of them 1s. So there's 4 ways to look at inputs. Right? 4 combinations of 2 inputs of 0s and 1s. And then if you want to look at how many ways can you group these together, there's 6 ways to group them. Again, that's not super important, but if you're wondering why there are 6 logic gates, it's a math combination thing. Okay, let's talk about all of those combinations. So you have an AND gate. This checks if both inputs are a 1. So it only gives out a 1 if both inputs are 1. So if you have your logic table, which we'll show in a minute, you'll see that. An OR gate checks if either input is a 1. So all it cares is, do I have any 1s coming in? If it does, great, it gives out a 1. An XOR, or an exclusive OR gate, checks if there's only one 1 coming in. So if both are 1, or if neither are 1, then this would say that's bad. But if the first one's 1 and the second one's 0, that's good. If the first one is 0, the second one is 1, that's also good. And when we look at the tables, I think these will be clearer. So these are your kind of first 3 that we look at, and the second 3 are just the opposites, or the inverses of these. You've got a NAND gate, or a not AND gate, and it does the opposite of an AND gate. So it looks for when is it anything but both of them being 1. A NOR gate, or a not OR gate, it does the opposite of OR, so it looks for, is there nothing coming in? And an XNOR gate, or an exclusive, a not exclusive OR gate, something like that, does the opposite of an XOR gate. It looks for, is there the opposite situation of only one coming in? So that was a lot of kind of confusing wording potentially, but this chart should help make sense of that. So to go through them again, we have our AND gate, which says they only want to say it's true if both are 1. So you see in this last situation, that's the only one where we get a true result. An OR gate says as long as there's at least 1 coming in, because it says is A or B, is the first input or the second input a 1? And in that case, yes, these are all true. A XOR gate says we only want one of them coming in to be true. So that's why we see in the second and third rows, we have the true output. Notice that in the first and the fourth, it gives false because they only want 1. So the first one's obviously false because neither are 1. The fourth one is false because both are 1. And the X here says we only want one of them. The NAND gate is the opposite of the AND gate, and so you see that's why it highlights those first three situations. The NOR gate is the opposite of the OR gate, so that's why it highlights the first one. And the XOR is the opposite of, or the XNOR is the opposite of the XOR, which is why it highlights the first and fourth. At the end of the day, you don't need to memorize these. You can look at tables, you can review them or like look them back up, but you should understand that this is kind of all the possible combinations, right? You've got where just the first one is true, just the last one is true, where the first and second are true, you know, all those different combinations. So we'll do some practice with this, and then if you have any questions, feel free to let me know.